What I'm going to do today is to go over some of these formulas that we have on that handout that we have available in Math Zone. This ties in particularly with Chapter 3, Math 1103. And it's a lot on this sheet. So what I thought we'd do in little pieces is to go over the importance of these formulas and where they fit into the lesson. So as we see here, this is number 1. This is standard form of a linear equation in 2 variables, x and y. And you might say, well, what does that mean? Well, the letter A can be replaced with an integer, 3. The letter B can be replaced with 4, and C with 12. And you'll see how this ties in here very shortly. Another important formula that's related to Formula 1, we're calling standard form, is Formula 2, which is the slope-intercept form of the linear equation, again in 2 variables. Now, how did we get from Formula 1 to Formula 2? And the answer is, in Formula 2, we solved for the letter y. So I think that's the first thing we're going to do. We're going to take this example and solve for the letter y and go over the techniques involved. So we're interested in 4y. Now to get the 3x on the other side, we're going to use that shortcut of called transposition, or subtract 3x from both sides. So transposition is just taking this term, bringing it across to the other side. When it crosses the equal sign, I say it just changes its sign. Or subtract 3x, this becomes 0, and then there's our 3x on this side. Now notice the 12 is still there. So we're well on the way of isolating what y is. And then from Chapter 2, you get y by itself by dividing both sides by 4. And the 4's cancel out here. Y equals a negative 3/4 x plus 3. So this is in standard form. This is in slope-intercept form. Now, since this is sort of a summary, and hopefully you have some information about it before you go in, let's look at this letter M right here. This letter M, by definition, is the slope. And this letter B, right here, is the y-intercept. That is where this particular line will cross the y-axis. It's going to cross it at B. And B happens to be 3. So we would go 1, 2, 3. We have plot the y-intercept. Again, there's lots of stuff going on here, but just to show you how it sort of integrates into the lesson, we then take a look at what the slope is going to be. Well, in this case, the slope is a negative 3/4, I should say. And how do you do that? Well, again, lots of stuff going on, but quickly, slope is the letter M, and it's a relationship of y units to x units, or rise to run. And this happens to be negative. So what I tell my students is you do the run first. Think of it as a negative 4 from this point. So we'll go 4 units to the left. That's the negative direction. And then now we're going to do the rise up of 3. And again, I don't have graph paper, so I'm sketching this in. And this is what your graph will look like. So this graph, this line, is an actual representation of this particular linear equation in 2 variables. Now you might say, how many points are there along this line? Well, since there are arrows on the ends, and these go on to infinity in this direction and infinity in this direction, there is an infinite number of points along that particular line. Let me erase this one, and let's go to graph this one, again using the method we just used. So we know this will be our y-intercept, which will be at 2, and this is our slope. And it's always a good thing when you write slope to put 3 over 1. So you realize there is a run of 1, which is our x. So there's our run of 1, and it's positive, so we're going to the right. And then our rise of 3. So this would be our graph of that particular line. Again, using the technique of slope-intercept, plotting the y-intercept, then from that point, plotting the slope. That's sort of what these first 2 formulae are about. I'm going to show you one other method that we do cover on that worksheet. I'll leave all of that there for now. And that is when we do an equation that's in standard form, one of the good techniques to use is a T-chart. And I call this a special T-chart, where we will find what the x and the y intercepts are. That is, where in the equation it will cross the x-axis, that would be the x-intercept, the y-axis, that would be the y-intercept. So in this first case, we're going to solve for the y-intercept. When x is 0, this will be what y is. So we go right up here. When x is 0, this becomes a 0. We divide both sides by 4, and we get y equals 3. Now when y is 0, right here, 4 times 0 is 0. We're going to now divide both sides by 3, and we get 4. So we would graph that, I guess I can use this spot here, by saying 0, 3, 1, 2, 3, there's our y-intercept, and then 4, 0, 1, 2, 3, 4, and there's our graph. And you'll note that that was similar to how we did this one. We said the y-intercept was 3, and we didn't have the x-intercept, but we just plotted that slope, and we got the same graph. So there is a brief review of standard form, slope-intercept form, and we're going to do some more about slope in the next part. We're now going to take a look at Formula 3 on that worksheet. And this, by definition, the letter M is slope. And if we have 2 ordered pairs, 2 sets of coordinates, we can put them into this formula through substitution and find the slope of the line. So as we look at this, we're going to take our y sub 2, which is a negative 2, And in the formula there is a negative. And then our y sub 1, which is a 2. And that's going to be over our x sub 2, which is 4, minus x sub 1, which is 3. So this gives us a negative 4 over 1. So the slope of that particular line carrying those 2 points is a negative 4. Now, as you do Math Lab, you're going to have lots of practice on doing slope. So I want to bring it in at this time, and basically this is how you do it. A key to remember is if this is negative in the formula, and if the y sub 1 term is negative, you have a negative and another negative, that term will become a plus. Something to look for as you do items like that. So I've added the title of this formula, slope formula, for number 3. And number 4 is sort of related to this one. It's called the point-slope form of the linear equation in 2 variables. And you might notice something, that here there is a slope right there. And here is a y sub 1 and a y sub 2. That is one of the ordered pairs. So what does this formula do? Well, if you have the slope, which we figured out from that set of ordered pairs is a negative 4, and you can use either one of those points, you can actually end up with an equation in slope-intercept form. So let's do that. So our m is going to be negative 4. I'll put that over here. Our equation is y minus our y sub 1. Our y sub 1 was 2, right there. And then it's going to be x minus our x sub 1, which is 3. So what I did, using point-slope form, this is the standard equation. I had 2 points, I found the slope. I'm now putting that slope into the equation through substitution, and then I'm substituting this first point, and that's my next step. Now, the next thing to do is to clear this parenthesis. You get y minus 2 equals a negative 4x. Now, a negative 4 times a negative 3 will give you a positive 12. You have to be careful when you're distributing so you get the right signs. And you say, now we're almost at our slope-intercept. But we have this to get rid of, in a sense. So we're going to transpose it to the other side, just changing its sign. That becomes a plus 2. Or again, we're adding plus 2 to both sides. Just a little shortcut method. You can erase that now. And this is going to become 14. I now have this equation in slope-intercept form. But suppose they said they wanted it in standard form. Well, actually in this case it's pretty easy, because all we're going to do is take this term, transpose it to the other side. When it does, it becomes a positive 4x plus y equals 14. And there is our equation that originally started with 2 points. We found the slope. The slope was negative 4. We then put it into formula 4. through substitution, and we got the slope-intercept form, which is number 2, and then we converted it to number 1 standard form. Again, there's lots of stuff on that paper as you do your quiz bees and your practice. Hopefully you'll pick up and develop mastery. As we continue to go over this form, I'm not sure how clearly it's going to come out, but we are now going on to Formula 5 and Formula 6. Now these are interesting formulas. They're sort of related to slope-intercept and actually standard form, but I'd like to go over something for just a moment. We see the ordered pair. The typical ordered pair is x comma y. Well, sometimes the letters A comma B are used to substitute for x comma y as an ordered pair. And it's particularly useful when you look at Formula 5. So if they said they wanted you to draw a line, a graph, of this equation that's in this form, and let's say it was y equals 3, then y equals b, what is in the b position here? Well, it's a 3. And what did we say about b up over here? This b is the y-intercept. So what they're telling you in this particular equation, they want you to draw a line through the y-intercept. That if they tell you an ordered pair, that's this value of y, it's what's in the b position, you're just going to go to that value of y, which is 3, 1, 2, 3, and draw a horizontal line. So equation 5 is an equation for a horizontal line. And one other thing I've put here as a little review on that sheet is that the slope of a horizontal line is 0. So we're just trying to give you kind of an interpretation of what's on that sheet and how it fits in. All right, here's another equation. 6, x equals a. Well, what this equation, when you graph it, it's the equation of a vertical line going through point A. That would be an x value going through point A. So this equation would be x equals -2. And there's our -2. And there's our vertical line through it. Interestingly, the slope of a vertical line, we say, is undefined. When you do it, you're going to do, let's say, slope is going to end up with something like 3 over 0. And anything over 0, we say, is undefined. In this case, when you do the slope, you're going to get something like 0 over 3. So 0 divided by any real number other than 0 is 0. So again, a little short review of those two formulae. To continue on in that first column on the left of our worksheet, example 7 deals with sort of a hint as opposed to a formula, that if you find the slope of one equation is the same as the slope of another equation, but the y-intercepts are not the same, you're going to end up with lines that are parallel. So here the slope is the same, but this y-intercept is different. So these lines are parallel. And that's just a little reminder of that particular illustration. Number 8. Now in this case, we're saying if we multiply the slopes, the slope of the first line times the slope of the second line, and our product is a -1, such as 1/2 times a -2/1, the results of this is a -1. So if this were the slope of our first equation, this was the slope of our second equation, we say in this case, the product being -1, that these slopes are perpendicular to each other. And it's an upside down capital T is the symbol we use for perpendicular. So if we put a little right angle there. So if we were to draw these, we'd have one line that went like so, the other line that went like so, and this angle would be a right angle. So we'd say these lines are perpendicular. And the little hint, the little recipe, is that if we multiply the slopes and the product is -1, these lines are perpendicular. So as we continue, Formula 9, Formula 10, and these again are more hints than formulas, and you'll notice that these are similar to our slope-intercept form. Our slope-intercept form is y equals mx plus b. Well, this is y something mx plus b. And this something I'm referring to is an inequality system, inequality sign. And we see that here too. Now there are 4 inequality signs: greater than, less than, greater than or equal to, less than or equal to. So here we see greater than or equal to. So I'm going to give you some background on how to graph these. And basically, when you start to graph, you use that technique in which you plot the y-intercept first, which is our b, which is a +1. We then go to our slope, which is 2. And then remember, that's 2/1. It's positive. So we're going to go over 1 and then up 2. Now the next part is typically you just make a solid line. But here and there's a little difference. And when you do your math lab practice, what you have to choose when there is, well, when there are these two signs, this is going to be a solid line. When it's just greater than or less than, this is going to be a dotted line. And that tool is available for you from the tool palette on the graph. So here, which one are we going to choose? Well, it will be the solid line. So we're going to do a solid line through that. And that's sort of the basic part of our graph. And that would be if it were equal. But here it says greater than. Y is greater than. So we have to do some shading. And one of the rules that I mention to my students is if a positive y is greater than, you're going to shade above the line. Okay? Now, one of the hints the textbook gives, and we want to mention here too, and let me just change colors for a moment, is to use what is called a trial point. A trial point would be something like this. You put a dot right there, and the coordinates of that point would be a 0, 0. Well, we then put that into this equation. So they're saying y is 0, so that would be 0, is less than or equal to 2 times 0 is 0, so this becomes 0, and this is a 1. So we have basically the statement, 0 is greater than 1. 0 is greater than 1. Is that true? And you think on it and you say, no. So this is not the area where you shade. You shade on the other side of the line. Because if you shaded here, that's not true. And that's the other test. So let's do this one over here. Again, this is practice on how to graph. And we have our y-intercept right there as 2. Our slope is 3 over 1. It's positive, so I'm going to go over 1. And then now my rise is up 3. But notice we have just an inequality sign and no equal. So what kind of line are we going to use? Well, dotted, and that's a choice you have. But now we have to determine, where do we shade? Well, if we use that special technique, a positive y is less. When a positive y is less, we would shade under the line. And going to our trial point. Again, a good one is 0, 0. So if this is 0, and this is 0, and this is 2, is 0 less than 2? Yes, 0 is less than 2. Our trial point is in the correct place. That makes it a true thing. The other thing I want to mention about inequalities is that as you look at inequalities, all of these points that are up here are solutions. If you just have an equal, the only points are the ones along the line. But when you have an inequality, all these points are true as well. So your bucket of paint, that's kind of a fun thing that we have in math lab. You have to pour that paint, you have to have the right line, and you have to have graphed the equation correctly, or the inequality.